My name is Stefano Mondino. I work here in this Turing for Synesthesia, which is the company who's hosting this event, this great event, by the way. Thank you for coming again to the event. And I have been living here in Torino since I was born, and it's a great pleasure to host you here in my city. It's really amazing for me to have such a great community here. My work in synesthesia is, I'm the technical leader for the mobile area. We do a lot of application, an insane quantity of applications during the year. I think we started in 2012, and we reached, I think, 100 of applications developed and built for our customers. And thank you, by the way, to my team, which is here to support me. And okay, so these are my contacts if you ever need my information about me. On my GitHub, and at the end of the day, I think I'm going to publish everything I'm going to show you today. So, what's going on today? Today is about RxSwift, which is a very opinionated framework. Someone loves it, someone hates it. I love it, of course. I've been starting with Rx programming with, I think, in 5 years right now. First with reactive Cocoa on Objective-C, and then switch over to RxSwift. We're also talking about RxCocoa, which is the companion for RxSwift for iOS, macOS, and whatever. And then live coding again, like Tim. It went well for him, so what could possibly go wrong for me? I think almost everything, but anyway. And I want to make a point, like Christophe this morning said about reusable coding, and how can make our code in Rx to be reusable, and how you can bring the same stuff, the same cool stuff you do with RxSwift across projects without having to rewrite it from scratch every time you start with a new project. I'm going to give you a quick overview about RxSwift. How many of you are using in production RxSwift? Can you raise hands? Use? Why not? Come on. That face, it's what I don't want to see.
No, I want to use it, but it's not possible right now in our project. So.
You're not the first, and you won't be the last to tell me this thing. Anyway. Okay. RxSwift basically is about FRP, which is functional reactive programming. The best way we can describe RxSwift is by describing it as a framework, a library that handles streams of values over time, which is at the same time a complex way to describe it, but it's actually the best thing. It's something that takes the variable of time out of your programming, because you don't have to worry about asynchronous working, but you just put together a chain of events and you do whatever you need without waiting, without callbacks and whatsoever. The cool thing about the framework is that you can chain, combine, you have a lot of operators that you can put together and create really cool stuff. I like to describe it like this. Everything is built around the concept of observable, which is an object, a plain object, that encapsulates a job. I call it a job. You can do work, you can do sets of function, call it whatever you like. It's some things that it's not immediate, that cannot immediate complete, and it's something that can produce not only one value over time, but many. That's the main difference against the future and promises we were discussing before with Tim for Vapor. The cool thing is you can create a lot of these objects that encapsulates logic. These logics won't even start until you call over the observable a method that it's called subscribe, or any derivation of it, that will actually execute the job, and whenever any value, any output will come out, will notify you on the next thread. And whenever you need to dispose or cancel this job, you just have to call dispose over the receipt, the subscription this method returns you. We have three main channels. I like to call them channels. I don't know if it's the right wording, but it works for us to explain. The next, the error, and complete. So an observable emits on the next stream, the next channel, any kind of value. It's a type safe value. You know on compile time which kind of value you're going to receive. Every time you're going to receive an error, the chain will break, and you won't get any more next. And when it's guaranteed that your job is completed, you just send a complete event, and at the same way with error, you will know that you will never receive any next again upon that subscription. And of course, we have the operators for RxSwift, which are useful like for functional reactive programming. It's like the Swift operator, many of them, but they work over time. We can imagine an observable like an array or a collection that emits value over time and not all at the same time. So you get map where you can take a next event and transform it in some other thing meaningful to you. For instance, you get an observable of strings, and you can transform those strings to uppercase, for instance. You can filter each event while you get it on the next chain, and filter out, for instance, every string who doesn't have at least three characters, for instance. Or you get the flat map family of operators, for instance, flat map latest, that takes an input out of the next chain and returns another observable that it's immediately subscribed. So you can really chain some time-consuming operation, and you can sandbox it inside a single object and share it across all your application, your view models, whatever pattern you're using to build your app. By the way, today it's not about patterns, it's just about how this kind of framework can help you to develop faster. So as you can see, there's a lot of other operators, and I suggest you this site, which is called Rx Marbles. It's RxJS, but it's the same because Rx actually stands for reactive extension. It's a family of products built for reactive functions, and they are available for Java, for Kotlin, for JavaScript, for Swift, and I think many others, but I don't use those languages. And here, for instance, you can try with the marbles how your output will be, how your output will result. For instance, by merging two observables together, you get a full stream of stuff all in a single chain of event. Okay, and it's blocked. I knew this. I knew this was going to happen, but I did it anyway. Okay. So RxSwift is something that's available for all the platforms from Apple and also on Linux. You can compile it and use it for whatever Linux project you prefer. You may prefer. I think you can use it with Vapor as well. I don't know if it makes sense or not, but it's something that at least compiles on Linux. RxCocoa, it's the twin, and it always comes when you do iOS. It comes inside in the bundle, together in the bundle, and it's only available on Apple stuff. You can have it on iOS, tvOS, macOS, watchOS, and whatever, but no Linux. The cool thing about RxCocoa is that it's using the old Objective-C runtime and all the stuff provided by Apple to wrap complex logics of of Apple frameworks, for instance, UIKit, and bring you just a simple pre-created observable that do the stuff for you. So it's really, really powerful. It's really, really useful. And why did I call this talk about? I was talking about RxSwift for UI, because many times happens that people who approach RxSwift simply thinks that it's something related to network calls. I mean, oh yes, we can concatenate and combine network calls. I can call the first API, then when I get the results back, I can call the second API, and so on. This is true. This is amazing on the API side, on the model and data manager side. It's really important and useful. But sometimes we tend to forget about how many things you can do on the UI side. If you do MVVM for the data binding layer, this is really amazing. It's kind of complex to achieve and to understand, but when you do, it's really, really amazing. One funny thing about RxCocoa is that each NS object you get from Apple, from Foundation and UIKit, has this cool Rx proxy, which is simply defined like this. Oh, sorry. Each object gets a property. It is called Rx, which leads to a set of observables and stuff related to the reactive side for that specific object. This is achieved by extending the reactive object by specifying the base class you want to use it. We'll see that in a minute. It's really, really simpler than what you can think. For instance, if you want to observe the X offset of a scroll view or a collection view or whatever, you can use the already provided content offset property and just map the X value of the content offset that it's continually streamed on the next channel of this observable. It's really amazing because you can bind this X value, for instance, to whatever you need to drive. We're going to see that in a minute. And if you need something that needs to be driven, you can define a binder, which is this. Can you see the mouse? Yes. Which is a cool thing where you can put all your logic and will be called whenever an observable will emit an X value and do whatever you put inside. Oh. Well, there should be a nice GIF over there, but it's not working, but no problem. So this is enough talking. Let's move about. Oh, here it is. Just slow Wi-Fi connection. I love cats, by the way. So I definitely had to put cats in my slides, even if it's pointless. But anyway. So this is what we're going to do now. So we're going to code and live tests. We're not doing automatic tests. We're just trying out some of the codes. And then we're going to try to refactor this kind of code in a way that you can simply drag the Rx file around your projects and reuse the same concepts all over again. Code once and use forever. Well, anyway. So let's try this live coding thing. So I have a setup right here. Oh, come on. Just give me a second. And is this good for you? Okay, so you're not going to see the... Well, let's keep it like that. So let's also try the simulator and see if it's working, and then we can continue. Here we have it. Okay. So I've been setting up 4 scenes with 4 different approaches you can have with this whole RxSwift thing. And the first, we have a storyboard. I took the liberty to prepare in advance the storyboard. And the first thing I want to do is to display a simple timer, simple clock in this screen. So we have an outlet on our main view controller and a button. So what I want to do is try to use only RxSwift and RxCocoa to drive the current value of that label and display the current time. It's something, of course, you can do in many ways. It's not that, I mean, amazingly hard to do, but let's use something that RxSwift is giving us. And one first thing you can do is this kid here. This is something pre-baked in RxSwift, and it's an interval. Each x seconds, 1 second in this case, on the main thread will emit a next with a count. This count is going to be 0, 1, 2, 3, and so on. And we want to display the current time. So actually, we want to transform that useless counter. Can you see? Okay. In something different. For instance, let's get the date. This is just a date. It's not readable, so let's use some formatter, date formatter. And just give it a date format. And let's try by outputting the hour and the minutes and the seconds, of course, otherwise we would have to wait a lot. And okay, let's. Okay. So as you can see, we have something that right in this context, without having to deal with complex closures or delegates or whatever, it's simply transforming each second in a useless value here and returning the current date. And the nice thing to do is that we can bind this stuff to our label, which is an outlet you can see over there. Rx text property. Rx text, sorry about that. Rx text, it's a binder. That's it. It's kind of like a sink. Whatever you put inside, it do something on that and display it. And of course, as we have to put this subscription, because all of this generates a subscription inside a dispose bag, which is a trash bin where you put every subscription you need, and when you empty the trash bin by disposing the whole timer view controller, all the subscription get cancelled, so you don't have memory leaks and whatsoever. So let's define a global dispose bag. It's common practice to do this. And RxSwift will automatically put everything inside that. Okay. Let's try to see if this is working. I hope it will. So you will see 9:41, and then we're up to speed with our current time. If we need to get rid of that ugly 9:41 time, which is the placeholder I left in the storyboard, it's easier just to use the start with 0, which is subscribe to the interval. We usually would have to wait a second to get the first next in the output, but when you subscribe, the first time emit a 0. So force a 0 before everything else happens on the interval. In this case, when we relaunch our application, there is no 9:41 anymore. So it's really cool. What if we want to transform this in some kind of chronometer, some kind of more frequent update? Let's try with this. This is for milliseconds, and I'm going to use one every. This should be every 1/50th or 1/20th of seconds. It should emit a new value. If you take a look at this, I didn't change that much, and you have a nice thing here. Some kind of this kind of chronometers, you have to pause it for some time. So one cool thing could be, I had a start button, but let's imagine we want to stop, and while we're holding down the button, and then start again by where we were left. We can do this by combining events from the button. Let me show you, it's easier. We have a button, and we have this nice control event property, where we can use that, for instance, the touch up inside. And we also have the down part of it. So the nice thing, for instance, we can have the button press, and while we keep on pressing the button, the timer will start and show our values. And when I leave the button with the touch up inside, with by lifting my finger, the timer will stop. Let's see how we can do that. We can wait for the down value, and then flat map latest. That means ignore whatever void event you're getting from the button, and then return instead this observable. Let's try with this. What can happen? I'm not using the app, by the way, right now. So we see 9:41, nothing has started, but if I click the button, everything starts. And now I want this label to show the value only if my finger is down on the start button. So I'm gonna say to the framework that I have to take values until the up observable emits something. Sorry about that. And Rx has this amazing thing that it's called take until. And you can use it with a number, take only the first 5 elements and then quit. Or take until, for instance, that takes another observable inside. And we can have the up here. I'm clicking, I'm leaving, clicking, leaving. It's just a pointless example. I don't think no one ever could imagine to do something like that. But anyway, it's really simple to chain events from different part of your application, of your UI, or your data layer, for instance, and merge them together to work in a very simple way if you know all the operators. There's a little bit of study involved, but I'm here to explain some kind of nice tricks. So the second thing I want to do is to take our little friend here, the Swift heroes of today, and I've set up a simple scroll view with a very high content, and I want this to stretch accordingly and do the bounce effect you can see inside the Swift Heroes application. When you open a talk and you try to drag and over scroll the menu, you get the usual parallax we are all used to see in application like this. So I've been setting up a scene that is here, We have a, can you see that? Yes, amazing. We have a full screen scroll view. This little guy here has an height constraint of 300 and a scale to fill, sorry about that, an aspect fit content mode, okay, and the proper outlet and whatever. So what I want to do is to scroll the collection view, the scroll view, and see this this image to move outside with a parallax effect when I scroll up, and the image to stretch and zoom inside and towards your face when I scroll down. It's really easy with RxSwift. So let's try like this. We have this amazing, like I said before, content offset on the scroll view inside the Rx proxy. Let's get the content offset and map its Y value. The amazing thing is that I didn't even set a delegate for our scroll view. Our view controller is not the delegate at all at the scroll view. You don't have to fill your code with the useless delegate from Apple, because it's RxCocoa that with Swizzling, delegate proxying, and really cool and hard stuff to learn. It's taking care of it in the background. So if you just subscribe to this and try to debug whatever is coming out. Oh, sorry, not here, here. Try to see the scroll view here. You should be able to see in the next value. Can you see the here? We just bound the output to the log. Let's get rid of this and try to drive the image top constraint to the Y. How is it done? Is it done with this? Bind to image top, which is a constraint with an outlet to the storyboard. Rx constant. Let's try it again. Please work. Okay, so it's twisted because probably I've been setting the constraint in the storyboard. I have to reverse it. So it's either I reverse the constraint in the storyboard or just invert this guy here. So they're moving together right now. What if I want a parallax effect, so the scroll view goes over and the scrolling of the image it's slower? Just put some multiplier right here, like 3.0, for instance. So this means that the Y value of the content offset of the scroll view gets divided by 3 and bound to the parallax effect. So you can see they moving in a different way. So what if I want to, when I reach the 0, to bounce and stretch the image towards the user? It's really easy, because I have to, first of all, limit this value not to be over 0, I think. I'm going to max out between 0 and that negative value. This way, you see, by mapping every time the value, you get a very straightforward and very clear visual and state of what's happening. It's one thing after the other. It's really FRP style. Its function leads to another function, and you have a chain. And as you can see, I had to put min and not max. Sorry about that. Okay, so it's working like before, but when I go over 0, nothing it's happening. So what if I want to put this and bind it to the height constraint of the image? Just put the let's take the initial value, for instance, let it be the initial value equal to whatever value has the image height constraint upon the view did load. And then let's bind the same thing as before, but without dividing it, to the image height constraint. Like I said before, the image has two constraints, one from the top of the view and the other one is for the height. And we're going to take the maximum value between the height of the image, which is 300, it's fixed in the storyboard, and whatever will come from the out from the scroll. Maybe I have the minus sign switched over, but yes, I have. Well, that's why I already wrote it, just to be sure to not lose that time. Okay, that's true. Let's try simpler before. So you can see it anymore because it's twisted. So let's invert this again. Like I said, what could possibly go wrong? Okay, so it's something like this one plus initial value. Okay, now it's bouncing again. And I don't have the minimum, the limit, but it's worth pointing that it's really simple to do this kind of stuff. Maybe not when you're on a stage, but when you're at your desk, it's really easier. So let's try to take this kind of stuff and let's get rid for the bouncing for a minute, and let's see how can we take this thing for the scroll view and bring outside this view did load to have something that it's more reusable and can be brought across your project. So I'm going down over here and try to extend the reactive object, which is the proxy called Rx here. And let's try to add some kind of property of behavior that has this nice parallax effect. So you have to do this kind of extension where you extend the reactive object. Every NS object, like I said, has this reactive object. And you have to specify what is the base object this reactive object is made of. If you take a look inside, it's just a simple struct with a generic associated that it's initialized with a base. Each time you call the Rx extension on your objects, this init is called. So it's nothing fancy here, but since it's a generic, you can have a specific behavior on your types. For instance, we want all the scroll views to get a, let's say, parallax value, parallax variable that is a simple observable of floats. Okay, now let's take all these things. It's just simple calculations, but anyway, and bring those over here. So to actually access the base, we use the sorry, I'm used to use functions and not variables for this. Okay, sorry about that. You can have the base Rx content offset or simply just content offset because we are already inside an Rx proxy, and do your calculation inside here. For instance, we can have a value that we can use inside here, and maybe since we really like the 3.0 effect, we can just use it for a default value because it was cool, wasn't it? And we're going to return this. It's really hard to write over here, by the way. So, as you can see, the scroll view right now has this parallax function. It's double because we have the default value. We can just use it. And of course, it's still working. Not the bouncing effect, because I'm going to be back at that in a minute. Let's see a more complex effect for the scroll view. We can directly bind our parallax effect. Oh, sorry about this. Come on. We can directly bind this parallax effect to our two top constraints by passing it via this method, and we will get a disposable back. Let's comment out this one and try to do scroll view .rx bind parallax top, image top, and image height, dispose by dispose bag. Bouncing and going away. This is the only thing besides the setup in the storyboard that you will need to do in possibly every project you will do from now on to have this nice effect. So just set up two outlets on the constraints or program it via anchors or whatever. Take this thing, this extension in a file outside. For instance, I usually do Rx extension. I don't know if it's you can read it. It's called Rx extension here. Just drop it inside. You can drag this file whatever you want, and you have the effect back. You don't have to use fancy libraries anymore, or just for the parallax effect. Just let me check if it's still working. I hope it does. Yeah, of course. Okay. And just to be effective, let me show you. There we go. This is the only thing you need to do to build such a complex effect. So, I think I still have 10 minutes. Let me try to show you some very basic example of Carousel. Carousel are those kind of horizontal paginated collection views with stuff inside. And I want to show you, this is a basic setup with already pre-created image cell inside the storyboard. Don't use, of course, CollectionView cells inside storyboard. This is here just for demo purposes. But always use a xib file separated because it gets really messy, by the way. And let's say we have, I'm going to bring it back from here because it's quicker. Okay. I'm going to drop in this thing because it's really cool. It's something that the RxCocoa guys built around the collection view. So let's see what this is about. We have an observable of 10 elements, from 0 to 10 excluded, mapped to some kind of image, which is the usual mascot the Swift hero guy you've seen before. The amazing thing, it's a little bit risky, but they did this stuff where you can drive the items of the collection view with an observable of stuff. So let me better format this thing for you. So you get the cell identifier and the cell class you want to use from the collection view, and here's the configuration. Everything is bound to the objects. So you have an observable. Right now is hard-coded. It's emitting an array of 10 elements. You can have this bound to an API call or whatever you want. Firebase, for instance, if you take a look at the application for the Swift Hero conference, everything is made with Firebase, and it's continuously driving the UI, waiting for updates. And with this thing, you take the observable, whatever the output object is, as long as it's an array of objects, and you can drive the items of the collection view and configure it. I could, of course, it's better to have the data source explain in the classic way, but this is some kind of demonstration of how powerful is this RxCocoa thing. So, as you can see, we have this nice collection view. Problem is, we are not updating the current pager. How can we do that? You can have the objects to drive as well the pager control, the page control, number of elements. And of course, whenever the number of elements will change, object, it's an array of images, we need a number. So we need to transform the array into an integer, and it will be its count. If I run it, you can see that the pager has, oh, sorry about this, 10 pages, like how many I put inside, but it's not moving. How can I make the pager move? Well, this needs some maths. And the maths can be done by looking at the X position on the content offset like we did before, transforming according to the whole content, collection view content size, and dividing like this. Sorry if I copy paste it, but I'm running out of time, of course. Ah. Okay. Let's try this. I'm going to explain it. So like before, we have a map around the X position. We want to max it. We don't want that value to go below 0, so we are maxing it. And then we are transforming in an integer that's based across the width of the collection view content side. So you have the scroll value, it's progressive. You divide it with the collection view content size, and sorry, you divide it from you take the full width, you divide it with the collection view sides, with the frame, and then you have the number of elements. You multiply it from the current offset, and you have the current page, current index. So we have collection view current index, which is an integer, and you can bind it to page control dot rx current page. Okay, it seemed to work. So let's wait for the GIF because it's worth the whole talk. Come on, but anyway, I love the guy. I had to. So. Thank you for the patience. Sorry for the stuttering, for my terrible Italian accent in English, and I'm open for questions, of course.